theorem 5.3, diagonals bisect each other. So all of these, as well as both pairs of opposite sides parallel, all of these are properties of parallelograms. Which means, since a rectangle, a rhombus, and a square are parallelograms, then all of these have the same properties. They all have both pairs of opposite sides parallel, both pairs of opposite sides congruent, both pairs of opposite angles congruent, and the diagonals bisect each other.
They started.
Close.
No, it is.
Which means when we start talking about the properties of rectangle, rhombus, and square, we're already including these properties of parallelogram. The next theorems are going to be properties of just rectangles, or properties of just a rhombus, or properties of just the square. Since we're talking about a square being both a rectangle and a rhombus, then everything that's true for a rectangle will work for a square, and everything that's true for a rhombus will work for a square.
You're just going to shrink that theorem.
Yeah, let's not shrink that some more, thank you. Let's grab these. So, our first theorem, theorem 512, is a property of rectangles. The diagonals of a rectangle are congruent. So what we need is a rectangle, which by definition is a quadrilateral parallelogram with 4 right angles. So that's what we're working with, is something that has 4 right angles. If I label this, and then I start looking at the diagonals, I want to prove, in fact, that those 2 diagonals must be congruent. And I didn't quite make it into the corners. My given information is that ABCD is a rectangle. Which means what is marked on the diagram. What I want to prove, yes. I would probably go RECT dot.
You could draw a rectangle.
You could. You'd have to put right angles in it. Okay.
Read it like a 3, 4, 5.
With a rhombus, you could put 4 tick marks on a parallelogram, but you just say rhombus. Otherwise, it's not really abbreviation. So we're wanting to prove that BD and AC are congruent. What we are going to do is we're going to take a look at this triangle here and this triangle there. Can we prove that those 2 triangles, the one that is outlined in green or black and the one that is outlined in green, can we prove that those 2 triangles are congruent?
Yes.
They share a side. They share a side. Opposite sides are congruent. And they have a right angle. So, by side angle side. So triangle BAD is congruent to triangle CDA. By side angle side. So since the triangles are congruent, what allows BD to be congruent to AC? Because, yes, CPCTC, because corresponding parts of congruent triangles are congruent.
I don't like food.
You know, paying attention will help you infinitely.
I finally don't.
Paying attention, it really does teach you how to do them. So, the fact that you weren't paying attention when I did that proof does not make me think that you will ever learn how to do a proof. You have to pay attention. When we're doing a proof, all we try to do is help something make sense. So you look at what you do have, you try to make sense of that, and you try to show that that means, and you know how to prove triangles congruent, side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, like you know those. So you look for that in this to try to prove triangles congruent. And you do what makes sense. Theorem 513 now. Theorem 513 is property of rhombus. The diagonals of a rhombus are perpendicular.
How many theorems are we doing?
We got 3 more.
Well, we'll do as many as we can.
5 more.
The diagonals of a rhombus are perpendicular. Which means we need a rhombus here. What I know about a rhombus is it is a parallelogram that has 4 equal sides. So drawing a rhombus, I have to try to make it so it has 4 equal sides. I think I have it there. I tried. I always know that I'm gonna fail and that you guys are gonna help me know that I failed. And that's
Yes,
okay.
it's
That's
alright.
okay, I try. Okay? This is a rhombus, which means all 4 sides are equal. That's how I would mark that on the diagram. So when I am given,
You might not try to eat a Vegans before you learn.
all right. When I am given that ABCD is a rhombus, that's what it means on the diagram.
Wow.
And then I'm going to prove that that means that the diagonals. Oh, let me try again. That was a bad one. Are perpendicular. So we want to prove that BD is perpendicular to AC.
5. CBCTC.
And we're going to do that by proving we have congruent triangles. You're right. So the triangles that we're going to prove congruent, if I just prove that these 2 triangles are congruent, then I can have, in fact, this is perpendicular. Because once I show that angles 1 and 2 here are congruent, that would mean they both have to be 90. So, thinking about why do these 2 triangles have to be congruent? Diagonals bisect each other, right? So here we have those 2 pieces have to be congruent. And this side, segment CO, is shared, so that has to be congruent to itself. What makes triangle COB congruent to triangle COD then? Just side, 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 right? All three sides of those two triangles are congruent. Diagonals bisect each other, so O is a midpoint. Those pieces are equal. This one's shared. So what makes these triangles congruent to each other?
Side to side.
Right. So I have triangle BOC is congruent to triangle DOC. By side, side, side. Now I want to go through the fact that angle 1 is congruent to angle 2, so these lines must be perpendicular. What I'm looking for, Dustin, what I'm looking for is when you have intersecting lines that form congruent adjacent angles, those lines are perpendicular. We have a theorem that says that. It's in chapter 2. A theorem in chapter 2 that says chapter 2, that says if lines intersect to form congruent adjacent angles, then they are perpendicular. It's chapter 2, so start with 2 something. That's why it's not. It is 2.5. Theorem 2.5 says if angle 1 is congruent to angle 2, then those lines are perpendicular. Right.
I'm ready.
I know, that's why I'm waiting.
What? That's be helpful. You know what I see? San Francisco. Hold up, out. Yeah, that's finishing.
All right, our next theorem, theorem 514. Each diagonal of a rhombus bisects two angles of the rhombus. Okay, please be taking notes right now rather than talking and then deciding to write. That way I don't have to pause and wait for you. Each diagonal of a rhombus bisects two angles of the rhombus. Now, because we have a rhombus again, I need a parallelogram that's equilateral. And for the same reason, when I draw these diagonals, I am going to be forming four congruent triangles. Because diagonals bisect each other in a parallelogram, those triangles are all going to be congruent to each other by side, side, side. We're going to use that fact to prove that since angle 1 and angle 2 are congruent, I'll just mark them, not name them, I guess. And these two angles are congruent, corresponding parts of congruent triangles are congruent. Since these angles are congruent and these angles are congruent, corresponding parts of congruent triangles are congruent, then each of the diagonals must bisect the two angles. So, to begin with, we are proving that AC and BD each bisect two angles of the rhombus.
This one's where it's
I'm going to start with, since diagonals bisect each other, then all of these triangles, and I'll call that middle point O, then triangle COB is congruent to triangle COD is congruent to triangle AOD is congruent to triangle AOB by side, side, side. Are you writing these notes right now so I don't have to wait for you later? Well, I'm not going to give you that classroom exercise then because I'm doing it right here.
No, 560 plus.
So the diagonals bisect each other, so the triangles are congruent by side, side, side. This means that these angles that are marked are congruent. Because they're corresponding parts of congruent triangles. And since the marked angles are congruent, then those diagonals bisect the angle, because bisect means forms two congruent adjacent angles. So AD and BC each bisect two angles of the rhombus. Here, 515 is not really a property of a rectangle or a rhombus. Thank you. But it is a property that comes because of the properties of rectangle. So theorem 515, the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. this works is because of the properties of rectangles. So if we start with a right triangle, let me find a right triangle here.
Okay.
There's probably a better option for right triangle.
Yes.
Right there. So if we start with a right triangle, interesting.
What's the difference? What's the difference?
The reason why this one is better is because it is not isosceles. I don't want an isosceles right triangle. I want one that has two different side lengths. Okay? And then, if we flip this right triangle and rotate it, let's clone it first off, and then flip it, and then rotate it. Oh, I don't think that's exactly what I want. How do I get there?
I get you, yeah, no. Flip it again.
Okay, so let's undo, and let's just rotate it.
Yeah.
That's what we want, is just rotated.
No, negative.
I'm going to change the color of this so that it's a different color. So that it
Yellow.
looks different than the original. Thank you,
You're stupid.
thank you. I enjoy being called stupid.
No, not you, I was going to say,
Okay.
I can tell.
So now, if I look at triangle ABC, what we're going to try to prove is that the midpoint of the hypotenuse, you can find the midpoint of that hypotenuse because diagonals bisect each other by drawing this other diagonal. So when I draw that other diagonal, I am finding the midpoint of that hypotenuse.
And it is X.
And what I know is, since this is a rectangle, we'll call this other point D here. Since it is a rectangle that we have here, not only do diagonals bisect each other, but the diagonals are congruent. And if the diagonals bisect each other, and that's the midpoint of both of them, and the diagonals are congruent, then all of these pieces are going to be congruent to each other. Okay. Which means, if I take this other piece off, you can see that the midpoint of the hypotenuse of the right triangle will be equidistant from all three vertices, which is what we're proving here. So to write the proof now. What's that? Okay. So to write the proof, what we are given is that we have a right triangle ABC. What we are going to prove is that point O here, which is the midpoint of segment BC, and I guess I need to put that in my given. What we're going to prove is that O is equidistant from all three vertices. So I need to prove that BO equals OC equals AO. So to start the proof, I would say when I put the twin of this right triangle's hypotenuse to this right triangle, then I have a rectangle. So let's start with, we can form a rectangle from this right triangle. A congruent right triangle BDC. rectangle ABDC diagonals bisect each other and are congruent. Branson,
No,
be taking notes at the same time I'm writing them, so I don't have to wait for you.
pay attention. Form a rectangle with this right
Triangle and the congruent right triangle BDC.
Rectangle ABDC. Diagonal bisect each other.
There you are. Which means, which means, please let me finish this.
It's 1210, Branson.
Okay, which means that O is the midpoint of these congruent pieces, and BO equals AO equals CO.
Yeah, let me get the equal. It's over the midpoint. Body order is three of the
All right, thank you.
Thank you.
You can go to lunch. Have a happy Thanksgiving.
I'll try.